The way I am calling this to be a 3D thing is totally wrong. Hello, my dear friends. This is the confused physicist, and let's get confused together. Today's topic is what is the coordinate geometry? But disclaimer, in this video, I will mostly talk about the spatial coordinate system. But remember that I can form a coordinate system with a set of dynamical variables which follow certain rules. Now, I know this dynamical variable, such a heavy word, you might be scared from that. But please subscribe right now because in the next shots, I might explain that. Let's get into it. In this space of my board, I have an object. It's a very important object. This object does not have any length, it does not have any breadth, it does not have any height. And this object is hence a zero-dimensional object. And I will call this object to be a point. Now, if I move this point along one of the independent directions, then I will transition into a 1D object that is known as a line. And this is 1D because it at least has a length, right? Now, if I have this line and I move this line along another independent direction different from the previous one, then I will get a 2-dimensional object which is known as a plane, like boom, 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 boom. Okay, so this is a plane because it has a length and it's a breadth. Now, if I stack up these 2D planes one above the other in another independent directions, which is different from the previous two, I will get a 3D object, and you can call it a cube or a cuboid, whatever you want, and any 3D object. Well, so what did we learn from here? Important thing, that the number of dimensions equals to the number of independent directions. So, to represent an n-dimensional space, I will require n number of independent directions. Cool. Now, whatever I did till now, I will repeat this by sieving in more important details. Just focus. Now, again I have a zero-dimensional point. Now I move in one independent direction and I get a line. That's a one-dimensional object, right? Now I have formed a one-dimensional space, and in this space I can draw countless number of lines and countless number of points. Okay, which is of course allowed by the boundary conditions, right? But in reality, this can extend up to infinity. Both the ends can extend up to infinity. So that's why I told countless number of things. Okay. So in the one-dimensional space, I can have countless number of straight lines or lines, 1D objects, and of course zero-dimensional objects. Those are known as points. Now let us transition into a 2D space. That's a plane. But I said that, a plane. And in this plane, I can draw countless number of planes or 2D objects like this, right? And also one-dimensional objects like lines, and I can also draw zero-dimensional objects like points, countless number of times, right? Now if I transition into a 3D space, what will happen? And I will draw the 3D space like this. Here I can have any number of 3D objects like this. Okay. And I can of course have any number of 2D objects and any number of 1D objects, any number of zero-dimensional objects, right? So what did we learn from here? That in higher dimensions, I can embed the objects with similar dimensions or objects with lower dimensions, right? Now, I have a 3D space. Okay, I have a 3D cube, a 3D space over here. Now the problem becomes, if I have embedded a zero-dimensional object into the higher dimensional 3D space, what's the location of this point? And in this case, the importance of coordinates comes. Now, many of my viewers who have been through their books, they know that I will need 3 numbers to locate a point. But my question to you guys is that if the point is a zero-dimensional object, why do I need 3 numbers? It is zero-dimensional, I should require no numbers at all. But my dear friends, those number corresponds to the independent directions, not to the point. And hence, now I can draw the coordinate system. So my dear friends, till now you learned that those 3 numbers corresponds to the 3 independent directions. Now my question for you to comment down below is that in your geography class you have learned that to locate a position of a certain place on a map of this world, we need 2 numbers corresponding to latitudes and longitude. If our Earth is a 3D object, why do I need only 2 numbers? If you have understood something from this video, please comment down below. So this is the coordinate system. I mean the 3D coordinate system, and these are the independent directions about which I am talking from the starting of the video, and I will give them their canonical names X, Y and Z, and they are 90 degrees with each other. This angle is very important. I will explain later in this video, so stay tuned in this video. And this point is known as the origin. It's like the landmark you provide in the Amazon delivery system such that it locates your address. Likewise, to locate the point, I have to have this origin. I have to get those numbers relative to this origin. And what are those numbers? Those are unique numbers. Why they are unique, I must say. First of all, I have the point over here, and the unique numbers are A, B, C. Why are they unique? Or the question should be, how are they unique? Because for X, I have a unique A. For Y, I have a unique B. For Z, I have a unique C. What if these values are not unique? Then the point or the object will be at multiple places at the same time, and that's not possible. So the rule number 1 to have a relevant coordinate system is uniqueness. Uniqueness of what? These A, B, C's are known as coordinates, right? Coordinates. Uniqueness of coordinates. Now, I have to know how to get this A, B and C. To know that or to understand that, I will transition into the 2-dimensional system for simplicity. So this is the 2-dimensional system. I have X and Y. To locate a point in this system, I need 2 unique numbers, A and B. A corresponding to X and B corresponding to Y. How will I get A? If I drop down a straight line from this point onto the x direction, perpendicular to the x direction, then this point, the distance from the origin to this point is a. Okay, and this is known as projection. To understand more about this projection, you will have to wait for my next video, which is on the topic vectors. Similarly, to get this b, I have to drop down a straight line onto y such that it is perpendicular to the y, and the distance from origin to this point is b. So simple, right? But now notice that this line is parallel to the y direction, and this line is parallel to the x direction. This in mind. I will ask you later. Now I have to solve the problem why they are at 90 degrees. Why is it important? So let me clean this up and draw the setup again. Now this is the setup again. This is my x and this is my y. Now suppose if I only move along the y direction. Keep in mind this is 90 degrees right now. So I'm moving only along the y direction, and each point on this trajectory is corresponding uniquely to y, right? But the x values are unchanged, right? So I can isolate the problems in two. Like if I have a problem in this y direction, I can solve it first and I can then go into the x direction, because the change in y is not affecting anything to x. So x and y are independent. Okay. Now, if I shift into an oblique set of coordinates, what will happen? Now this is the oblique set of coordinates. Such that this is x and this is y. And this y is inclined at an angle 60 degrees to the x direction. Now, if I move along the y direction, such that each point on this corresponds uniquely to y. Now suppose one of my friend is walking with me along this x direction. So my position with respect to him will change on x direction, right? So somehow a change in the y is causing a relative change in the measurement on x, and hence x is dependent on y. And this is introducing another complexity into the problem, that is the relative change in the measurement. For that, I have to solve more rigorous mathematics. Why do I need to make my life harder? That's why I need orthogonal set of coordinates. I mean the coordinates which are 90 degrees with each other. So the second rule to have a relevant coordinate system is rule 2 is that the directions are at 90 degrees to each other. Okay. Now that's why I said relevant coordinate system, because I need to make my life simpler. It's not that the oblique system does not exist, they exist, but that creates more problems. Okay. Now I told you to wait for my question, right? So I will draw the two systems again and I will throw the question at you. Remember, when I was dealing with the orthogonal set of coordinates, then what was happening? I told that this line is parallel to the y direction. While I was dealing with the oblique system, I drew the line that is not parallel to the y direction, right? What if I had drawn parallel to the y direction? If you know the answer, comment down below. The way I am calling this to be a 3D thing is totally wrong. This drawing is wrong. This is not a 3D thing. But the 3D coordinate system is somewhere here. I am projecting that 3D coordinate system on this board, right? And while projecting it on this two-dimensional board, weirdness is happening. Rather, the required language for geometry is getting affected. You want to know why? Remember your class 9 notes about Euclidean geometry. Euclid had 5 postulates, and the 5th postulate talks about if I have 2 lines and if I have a third line such that it has 2 angles, interior angles theta 1 and theta 2. If the sum of the interior angles theta 2 equals to 180 degree, then these lines remain parallel. They continue to be parallel lines, right? But if they are somehow less than 180 degrees, then these lines will converge at a point somewhere, right? Now imagine a scenario like you are walking in the middle of a deserted road. You know the edges of the roads are parallel to each other. If you don't believe me, just have a chalk and draw a line on the road and just check the sum of the interior angles. You will get 180 degree. Cool. Now when you look at the further end of the road, then you will see that the edges of the roads are converging somewhere. The parallel lines are no more parallel. This is because the language of geometry is changing. From Euclidean geometry, I am transitioning into some geometry that is not Euclidean, because the 5th postulate of Euclid has been broken. And that geometry is known as projective geometry. Okay. Now, suppose this is the board where I am drawing the 3D system, and here I am, right? Here I am, and I am drawing the 3D system. Now, first of all, this is the floor where I am standing. And suppose the road is like this. The road is going like this. Boom, boom. The road is like this. But I am looking towards the further end of the road. While looking, my line of sight is somehow going towards this point. And hence, the parallel line seems to converge at this point, this very point. So in projective geometry, a line of sight corresponds to a point on this projective plane. Okay. Now the terrible thing happens. This projective geometry has a weird homogeneous coordinate thing. It's a feature of projective geometry. Suppose the point that I want to draw on my board is somewhere here. Okay, now this is my line of sight. Now this line of sight corresponds to a point on this board, right here. It's the point. But due to the homogeneous coordinate system, this point can correspond to any point along the line of sight. I actually don't know where the particle is. This creates a problem. Then what should I call this 3D coordinate system? Well, I will call this 3D representation or 3D drawing to be a representative of the 3D coordinate system. It's not the 3D coordinate system itself. And in many books, you will see that this is the 3D coordinate system embedded into a 2D system. Well, that introduces many complexities into the description. So I avoid that. I will just call it is the representative of the 3D coordinate system on a 2D board. Now, in this video, I have been talking all along about directions, right? Now, you know that if I have another quantity that is known as magnitude, and if I sum up magnitude plus direction, I will get something, vector. But my dear friends, if I tell you, vector is not merely something that has just a direction and magnitude. To know more about this, you have to wait for my next video, which is on the topic vectors. And if you like this sort of content, please like, share and comment down below. And please subscribe to this channel. This is Anubhav Datta and I am signing off.